But calculus, I can take the derivative by the limit, yeah. Thanks to Julie, how I get a 5. Calculus, we learned so much this past year about math and life. Calculus, there's nothing to fear. It's so fun, it's so fun, it's so fun, it's so fun.
We're learning min and max. It's a math rap, yeah, we know that's whack. It's something special and that's a fact. So pay attention cause this lesson's math. Take 'em to the bridge, derivative. Just set it equal to 0. What's the next step? Come on, you should know. Solve for x, you got your highs and lows. Take 'em to the lesson.
Today we are learning about mins and maxes. Our function is f of x equals x squared plus 2x plus 3, and it is bounded by the interval -4, 3. Remember, because these are brackets, we're including the x values -4 and 3. Our first step is to take the first derivative. By doing this, we get 2x plus 2. Next, we set the first derivative equal to 0. This means we get 2x plus 2 equals 0, and x equals -1. This is what we call a critical point.
We're learning mins and max. If you weren't listening in Julie's class, this will help make sure your test you'll pass. It's calculus time, so get off your ass. Take 'em to the bridge, make a chart. Use critical numbers to make intervals. Plug in points and check them all. If it changes, you gotta rise and fall. That's a min and max.
The next step is to make a chart. We want 2 rows, the first one being x and the second one being f prime of x. Use your critical point to make intervals on each side of the graph to determine whether the graph is increasing or decreasing. Choose any point within your first interval and plug it in to the first derivative to see if it results in a negative or positive number. In this function, we got a negative. Next, at our critical point, we know the first derivative equals 0 because that's what we previously solved for. And finally, use any point in your second interval and plug it into the first derivative to see if you get a positive or negative number. Here our function goes negative then positive, which means the function is decreasing then increasing. This gives us a minimum. Remember, our interval was -4 to 3. Because this is a closed interval, we must check our endpoints to see if a minimum or maximum occurs there. To do this, you plug in the endpoint into the original function. After this, we got the value 11. Next, you plug in your second endpoint into the original function, and here we got 18. Because 18 is greater than 11, 18 is a maximum and is the highest point on the graph. Here is a visual representation. You can see at x equals -1, the slope of the function is 0. Before this point, the function is decreasing, and after this point, the function is increasing. This is how we know a minimum occurs at x equals -1. If you look at the interval, you can see at x equals 3, the function is higher than when x equals -4.
We've learned mins and max. Hope you you had a great time learning math. Congrats, now just go get a snack. But if you're still